Hello! Today we are going to blend our knowledge of k-means clustering with the lab color space to tackle a real-world task, identifying the color palette of an image. So grab your coffee or tea, get comfy, and let's dive in. In our previous episodes, we set up our virtual environment. Today we just need to install one more package, which is called scikit-learn, and after that we are ready to go. Let's outline our task. We start with a colored image, which we can store on our computer as a 3D numpy array representing RGB values. Our goal is to apply the k-means clustering method to this image, assigning each pixel to a cluster. The centers of these clusters will form the color palette extracted from the image. In machine learning and data science, preparing input data is crucial. Currently, our image is a 3D numpy array, which isn't straightforward for direct k-means application. But let's break it down. Our 2D grid has each entry with 3 values for red, green and blue. To find the color palette, the pixel position on the grid are not relevant, so we can transform our data into a format with h multiplied by w points in 3-dimensional space, where h is the height and w is the width of the image. Here's how we do it. We treat each pixel by its RGB values, ignoring its location. This transformation is simple with the reshape method from the numpy package. Now let's switch to VS Code and make it happen. In the beginning we should import all necessary packages and methods. Let's start with a simple example to understand the reshape method. First we will create a 1D numpy array, and now let's convert this 1D array into 2-dimensional array using the reshape method. The key thing to note is that this process is reversible, and we can convert it back to 1-dimensional array by using the a.reshape of 9. Now let's try this with an image. We will generate a random image of a very small size, say 3 by 3 pixels. Here we have obtained random float numbers from 0 to 1 that we can use to create an image. We just need to convert it to the proper shape. So let's reshape it to the size of 3 by 3 by 3. Now here is a trick that we should understand. This command will reshape our image into a 2-dimensional numpy array with the following dimensions: w multiplied by h and 3. The -1 value acts as a placeholder for a dimension size inferred by numpy, ensuring that the total number of elements remains constant. Great! Now let's load the real image that we want to cluster using the k-means method. Today I will use the picture of the rock Lee. And we want to convert our image from the RGB color space to the lab color space, because Euclidean distances in the RGB space do not accurately represent human color perception. Let's convert it by using the RGB to lab function from scikit image library. After this conversion, we will still have an ND array of shape HW3. Now let's reshape our image to get points in 3-dimensional space. Now let's apply the k-means implementation from the scikit-learn toolkit. 6 here is the number of clusters we want to find. Let's check the centers of our clusters. Centers represent the colors for our color palette. The output is then the lab representation of colors. Let's transform them back to RGB and display them using matplotlib. Here we convert lab colors to RGB colors, and then we convert image from float to ubyte to get values for RGB in an interval from 0 to 255. And after that we use image show method to show our color palette. That was easy, right? Let's print the RGB representation of the colors we found by using the print colors. We already know that the colors in RGB can be represented by three numbers in the range of 0 to 255. In real life, people often use the hexadecimal representation of colors, which is very popular in web design and programming. In hex notation, each color channel is represented by a two-digit hexadecimal number, ranging from 00 to FF, equivalent to 0 to 255 in decimal. Let's write two functions to convert RGB to hex and hex to RGB. Now let's try to convert our decimal RGB colors to hex by using the following statement. You can now copy these values and paste them into most programs. And finally, we can achieve image compression by using image clustering. Right now we have found the 6 most dominant colors for a given image. Now let's create a new image using only these 6 colors. This can be a crucial step in data preprocessing for some machine learning tasks. Let's create such an image. Wow! Even with just 6 colors, we can accurately preserve the information about the original image. There are many other ways to apply clustering to images, which you can explore on the internet. That's it for today. Thanks for sticking with me up to this point. Take care, my friend. See you next time.